This is Sung, and I'm the Principal and Director of Sky Academy. And in this episode, what I want to do is build on the foundation that we've established in the concept that we're going to be dealing with called motion. Alright, so just to kind of recap what we did on motion, I've got like a little bit of a flow diagram happening here. And basically, we're looking at three kind of distinct rates, or three quantities and their rates, right? So we've got displacement, velocity, and acceleration. So we've got those three concepts, right? To move from displacement to velocity, you differentiate. To move from velocity to acceleration, you differentiate, right? And when you differentiate, you do so with respect to time. Okay, so time, or t, is the variable with which we differentiate with respect to, all right? When you're going the other way, when you're going from acceleration to velocity and from velocity to displacement, you are going to go from acceleration to velocity to displacement by integrating, which is the reverse process of differentiation, right? So I just want you to be aware of that, okay? So let's launch straight into an example where we might apply the principles in this diagram to the right, to your left, okay? So let's have a look at this. So a point, all right, so you got a point moving in a straight line, all right, and the line is s meters from the origin O at time t. And basically the path that the moving point makes follows this rule, right, this function, all right? And then it says find an expression for the velocity and acceleration. Now s is the displacement. It is s meters from the origin, all right? So in order to work out the velocity and the acceleration, you just need to find s dot, all right? Well, that will give you the velocity, so let's work that out. You differentiate with respect to t, you get 6t squared minus 30t plus 36. That's going to be your velocity. Your acceleration is going to be s dot dot. Does that make sense? Now that's going to be the differential of, or the derivative of your displacement, which is that. Sorry, not displacement, your velocity, which is that. So that's going to be 6 times 2, which is 12t minus 30. Does that make sense? So this is going to be your velocity, and this is going to be acceleration. Alright. Then it says find the initial velocity and acceleration. Alright. Initial, whenever you see the word initial, what you're looking at initially is at the very beginning. And at the very beginning, what you can say is time equals 0. So whenever you see initial, what that means is time is starting at that point. Time equals 0. Initial means time equals 0. What you need to do is etch that into your brain, because when you do motion type questions, all right, there are key words and phrases that will pop up, right, that give you a hint as to what that means in terms of the variables that you've got. Okay, so initial is one of them, and initial means that the variable for time is equal to 0. So initial velocity is going to be equal to, so you put t into 0 here, that becomes 0, that becomes 0, so it ends up being 36. Alright, and basically what it is meters per second, right? Alright, and this one's meters per second as well. And then initial acceleration is equal to, pop 0 into there, minus 30 meters per second squared. Does that make sense? All right. All right. Now, Another key word, another word that you'll see is found in the next question. When is the point stationary? Stationary means not moving. What variable does that give us an idea about? Okay. Another one is at rest. When you see the word stationary or at rest, what that means is the velocity is equal to 0 because the particle's not moving, right? So basically, for C, what we're doing is working out stationary when S dot equals to 0, okay? So basically, substitute 0 in. Let's factorize. Alright, so it's 6 outside of t squared minus 5t plus 6. Now that becomes t, we can factorize that, okay? It becomes, using the cross method or the product sum factor method, that would become t minus 3, t minus 2. Yes? Alright, so in other words, the particle is stationary when t equals to 2 and 3, 2 seconds and 3 seconds. Does that make sense? That's the answer for part C. Part D says, at what time is acceleration equal to 0? Find its velocity and position then. So, you just have to make S dot dot equals to 0, gives you 12t minus 30 equals to 0, 12t equals to 30, t equals to 30 on 12, which ends up being 2.5. t equals to 2.5. Now, we've got to work out the velocity and position then. So what we need to do is work out the velocity at 2.5. That's 6 outside of 2.5 squared minus 30 times 2.5 plus 36, which equals to, let's work that out, 2.5 squared. So the velocity is going to be equal to, I plug that all into the calculator and I get a negative, which is minus 1.5 meters per second. Alright, and then the displacement, let's work that out. Substitute 2.5 into there, becomes 2 outside of 2.5 cubed minus 15 lots of 2.5 squared plus 36 times 2.5. Does that make sense? Work that out. Put that all into your calculator. Okay, I plugged all of this into the calculator and what I got was minus 152.5 meters. Okay. So, for part D, your answer was 2.5 seconds. At what time is acceleration equal to 0? Find its velocity and position then. Basically 2.5 minus 1.5 meters per second and minus 152.5 meters. Okay, so that'll be your answer to part D. Right? Okay, so in other words, the particle will have moved backwards and the velocity would be going backwards as well. Got it? The last question says, when is the velocity negative? Right? And basically, what you got to do is take the formula velocity, which is that, okay, and solve that quadratic as a quadratic inequation or inequality. So you've got E, basically, which is velocity, which is s dot, is negative when you've got that equation there, 6t squared minus 30t plus 36 is less than 0. We want when that is less than 0. Does that make sense? Alright, so basically we had this expression turns into this expression, 6 outside of t minus 3, t minus 2 is less than 0. Okay, and if we were to draw that graph, what you will realize is it's concave up, and you've got 2 here, you've got 3 there, you've got the graph going concave up like this, so it's less than 0, between 2 and 3 seconds, alright? So when is the time negative? Between 2 seconds and 3 seconds. Okay? And that's your answer for part E. Okay? Now I apologize that all of this is kind of squashed up. Okay? But that is how you do that particular question. Let's have a look at question 2. A particle is thrown upwards from 0 at 25 meters per second and has a downward acceleration of 10 meters per second squared. Find its velocity and height above 0 in terms of t. To what height does it rise? At what time has its velocity halved? So let's have a look at that particular question and how to do it. Basically what you've got is you've got a question where you've got the ground there, a ball is being thrown up into the air at when t equals to 0, v is equal to 25. Yep. A is equal to a constant minus 10, right? So that's x dot dot, and this is v, which is x dot. Yep. So what that would suggest is that I will start with acceleration, which is x dot, which is equal to minus 10. To get x dot dot, I integrate minus 10 with respect to t, which gives me minus 10 t plus c. Alright, so we start with the acceleration, which is minus 10. We work out what velocity is by integrating, yes, with respect to t, and it gives us minus 10t plus c. Now we know that with that, to work out c, we know that t equals to 0. When t equals to 0, v equals to, or x dot equals to 25. So we know that 25 equals to minus 10 times 0 plus c. So c equals to 25. So the formula for velocity is going to be minus 10t plus 25. Does that make sense? So find the velocity and height above 0 in terms of t. Well, we've worked out the velocity, which is just this component here. What we're going to do now is use that to work out the height. So the height basically is we start with velocity, which is minus 10t plus 25. We integrate that to work out the height. And that gives us minus 5t squared plus 25t plus c. And we know that x equals to 0 when t equals to 0. So that helps us to work out what c is equal to. So let's work out what c is equal to. 0 equals to minus 5 0 squared plus 25 times 0 plus c. So c is equal to 0. We work that out. And so x, the formula for the height, is just going to be that where c is equal to 0. So it's minus 5t squared plus 25t. Got it? So we've worked out part A. To what height does it rise? So now, if we're throwing a ball up in the air, it rises to a maximum height and then comes back down. What can you tell me about that height? Well, at that height there, the velocity is going to be a turning point. The velocity is going upwards, and then at that point, it starts its downward trend. So it's a turning point. So at maximum height, and this is part B, what we know is that x dot will be equal to 0. Does that make sense? Alright, so that's what we're going to be using. X dot equals to minus 10t plus 25, and we know that that's equal to 0. So let's work that out. Minus 10t equals to minus 25, t equals to 2.5 seconds. So at maximum height, the time will be 2.5. It'll take 2.5 seconds before the particle reaches its maximum height. Does that make sense? So in other words, to find what height it rises to, all right, the maximum height will be what x is equal to when t equals to 2.5. Does that make sense? So we need to substitute 2.5 seconds into that equation, right? So x is going to equal to minus 5 lots of 2.5 squared plus 25 lots of 2.5. Work that out. I'll put that in the calculator. And what I get is minus 31.25 meters. Does that make sense? So the maximum height reached, sorry, not minus, it's plus, is 31.25 meters. Got it? At what time will the velocity have halved? Alright, so basically half the velocity is 12.5. Does that make sense? 12.5, because the initial velocity was 25, so the half the velocity will be halved when v equals to 12.5, which is 25, half of 25. So basically what we're doing is we're working out when x dot equals to 12.5, 12.5 equals to, the velocity is equal to minus 10 t plus 25. Okay, bring that over to the other side. Let's have a look. So you got 10t equals to 12.5, t equals to 1.25 seconds. Alright, so the velocity will have halved after 1.25 seconds. Okay, good. So I know that there's a lot here. I know that it looks very convoluted, right? But what I want you to do is try and follow that. Practice a couple of questions at home, alright? Because really, when it comes to doing motion, it is just straight differentiation and integration. But what's tricky is being able to decode the question and apply that calculus to situations of motion. Okay, so let me stand to the side so you can get all that working out. And I want to thank you for watching. And in the next episode, I want to look at some interesting motion graphs. All right, interesting graphs that have to do with velocity, acceleration, and displacement. Thank you for watching.